Hi everyone. This is the second edition of AWS Container Updates from 2024. In our previous video, we covered all the updates up to reInvent, and we had some interesting announcement reInvent. So in this video, we'll cover all those announcements plus new releases that have happened since reInvent up to the end of 2024. I'm joined by my colleague Kaushal Goyal. My name is Rohit Singh. Both of us are solution architect at AWS and are also part of the container specialization. So without further ado, I'll pass it on to Kaushal to talk about the first release.
Sure. Let's talk about EKS Auto Mode as the first feature. It was the most talked about feature during reInvent 2024. And why it was so big? Because it aims to remove a lot of operational overhead from our customers. And how it does that? So as you can see on this architecture on the screen, with EKS today, when you launch a cluster, a Kubernetes cluster is launched where AWS manages all the control plane of the Kubernetes cluster for our customers, including all the control plane side of components, API servers, etcd. But then customers have to add compute instances to the data plane, install a lot of plugins like networking plugins, storage plugins to the data plane to make it ready to deploy applications on. What we have done with Auto Mode, that when you launch a cluster, Kubernetes cluster with Auto Mode on EKS, all of these things are done already for you. And the customers would then need to bring their applications, and practically they can run their applications on this pre-baked cluster and scale those applications as well. So it not only takes care of all the pre-installation of the components, but also the day-to-day management of that data plane. That includes scaling, patching of the cluster, right, repairing of the instances in the data plane, and everything else. So all of this has become possible via the use of EC2 managed instances. These managed instances have EKS optimized AMI, which is specifically built for Auto Mode, where this operating system of these instances have all the necessary plugins to run Kubernetes installed on it, right, as system processes. So you don't have to run these components as daemon sets within your Kubernetes cluster, and they run as system process on the cluster.
So with that, Kaushal, how does it change the shared responsibility model for our customers?
Yeah, I think that's very interesting fact of it, right? So you see with current EKS offering, a lot of control plane side of stuff is managed by AWS, and all the data plane side of stuff like cluster adding capabilities to the clusters, managing those capabilities, managing the life cycle of EC2 instances in the data plane is managed by customers, right? And it is their responsibility. With Auto Mode, we are trying to remove all of those responsibilities from customers, and these responsibilities are now owned by AWS, and that includes management of data plane EC2 instances, managing the operating system, patching those instances for any security vulnerabilities time to time, monitoring those instances for any kind of failure, and replacing unhealthy nodes with healthy nodes.
Let's see a small demo of EKS Auto Mode. So if I go to EKS console and create a new cluster, you see now there is an option to create a new cluster with EKS Auto Mode. And you can name your cluster as you want. I'm naming it EKS Auto Mode Demo. You can select the Kubernetes version you want to launch this cluster with and create a few roles. The first role is EKS Auto Cluster role, and this guides you to create a role with least privileges that you need. So I created a role here, use that role, and then the other role that I'm going to create is node IAM role that nodes in the data plane would use. Again, a role with least privilege that is required to run within your cluster. Selected the role, and you can now define a VPC that you want this cluster to be launched in. I used the default one and created this cluster. It is now in creating status and would take some time to come to active mode. So if I see it has two instances where it gets activated and few node pools. This is where you can see this is using Carpenter in the background, which is fully managed for you in the control plane. And you see there is a metric server running as add-on, but there are no daemon sets. And this is where you can see all the necessary add-ons that you need to run Kubernetes are actually part of the AMIs that data plane nodes would have. So now let's see if we can host an application on this cluster that we just created. You can see there is one node now in the cluster because Carpenter always look at an opportunity to optimize your cluster. So if I list down the nodes, there is only one node here in this cluster, which is C6G large size, and it has two pods running on it, which are metric server pods as we saw earlier. Now let's try to host an application here. I'm using an inflate workload, which is a sample application with pause pods, which don't have a lot of functionalities in them, but need one CPU to run. So let us create this deployment on our cluster. So I create a deployment file with the name as inflate.yaml. I save this file and apply this deployment on the cluster. So as I apply this deployment, you can see a new node has been added to our cluster with C6A large instance. It is getting warmed up, getting ready, and the new pod has been added or launched onto this cluster. Now, if I see all the pods on this cluster, inflate pod is there. And if I now go and scale this deployment to, let's say, 10 replicas, let's see how the cluster behaves. Does it auto scale? So you can see a new node has been launched by Carpenter in the background, which is now much more bigger size, C6A, 4x large instance, and it is ready and then hosting 9 pods of the application on it. Now, as Carpenter would again try to optimize this environment because our new node is not fully utilized, it is moving one pod that was running on previous node to this new node. And that's how you can see it is deleting the old node and just keeping the new one. So now you have all 10 node pods of these applications available and they are hosted on the new node. And the old node has been moved out. So with that, we saw how an EKS cluster can be launched with auto mode very quickly, and you can start deploying your applications on it, and it would scale automatically for you based on the application's requirement.
Sounds like a massive win for our customers with this release.
Yeah, it absolutely is. And I think the next release also tries to do the same. So over to you, Rohit.
So the next announcement is EKS Hybrid Node. EKS Hybrid Node is an add-on to one of our existing feature of running Kubernetes on-prem with a cloud-connected use case. So we have another option of customers using cloud disconnected EKS deployment with EKS Anywhere. So EKS Hybrid Node adds another way for our customers to run Kubernetes workload on-prem and running it on their own existing infrastructure. So with this feature, we are allowing our customers to manage their data plane nodes, which are running on-prem, and we're also supporting a number of plugins and add-ons which run on those nodes, and this is all delivered from our managed Kubernetes service. Now, how does it work? We're connecting the customer VPC in their AWS account onto your on-prem infrastructure using either a direct connect connection or a site-to-site VPN. Customers can also use their own VPN solution. And then there, when we create the cluster, we are enabling this there's a node CIDR option where we define the node and pod network IP addresses. Now with this feature, customers are able to use their existing hardware, especially if they have made investment in accelerators or they have specialized hardware they want to use and they cannot retire that just yet. This feature is available in all commercial regions and available with both EKS standard and extended mode.
One question over there, can it be used with bare metal as well?
Very good question. So customers can utilize both bare metal service as well as virtualized infrastructure in the form of VMware Nutanix. So again, they can use any of those platforms.
So let's talk about the next one, which is FIS experiments for network fault injection on ECS Fargate. As you know, ECS is a fully managed container orchestration service where you can run containers as tasks on the service. And FIS, which is Fault Injection Simulator Service, is used to inject faults in AWS workloads for chaos engineering experiments. So now with this release, we have added network-related fault injections into ECS. So let's jump on the console to see how which experiments are added. Let's go to FIS experiments and create an experiment template. You can name it whatever you want, and then click next. And then you can add actions to an experiment template. Actions are the fault injections that you want to do to your workloads, and these can be for different AWS services. In this demo here, I'm going to select ECS as a service where I want to select the actions. And when I select ECS here, see there are few existing actions like stressing out the CPU or killing a process on task. And now we can add network related actions as well, where you can simulate network faults within your ECS environment, and you can basically evaluate that if a network failure happens, then how your application availability is overall and what measures you have to meet your RTO and RPO requirements. With that, we can move to the next one. Over to you, Rohit.
Thank you. So next one you have is an interesting one related to Bottle Rocket. So our customers have been running HPC and machine learning workloads. Now for these workloads, there has to be low latency, high throughput inter-node communication. And for that, we have Elastic Fabric adapters. So these are network devices which accelerate the traffic which needs to go from one node to another in things like distribution, machine learning applications. So we have now made it available, that is the EFA on Bottle Rocket. Bottle Rocket is our purpose-built container operating system, and customers running container-based workloads want to use Bottle Rocket can run workloads like HPC and machine learning and make use of EFA adapter for those workloads.
Next one is node health monitoring and auto repair of nodes on EKS. And this one again is aimed towards reducing operational overheads from our customers. With this feature, when you turn a node auto repair on EKS managed nodes, EKS tries to identify which nodes are not healthy. It does the basic monitoring through scanning the logs of nodes, tries to identify whether kubelet is ready or not, or any component on the node has been deleted manually. If that's the case, then EKS would try to repair those nodes. You can enhance this experience by using one of the EKS add-ons called Node Monitoring Agent, where some additional failures on your nodes can also be detected, like networking not being ready, storage not being ready, and all of those conditions if found, then EKS will try to monitor, try to repair your node on EKS. With that, next one.
All right, so next one we have Elastic Container Registry. So Elastic Container Registry is a managed service which allows you to store both private and public container images on AWS, and these images are stored in a secure, highly resilient way. Now, in order for you to manage which team has access to which image, we had registry policies, V1. Although there were only 3 specific APIs that could be managed using the registry policy version 1. Now, in order for us to give our customers more control over which API actions are allowed for a particular AWS IAM principle, we've announced version V2. So now all the ECR APIs can be managed through registry policy.
Next one is EKS programmatic access to Kubernetes versions. And with EKS service, you get a EKS endpoint using which you can communicate with EKS service for a lot of actions. And this is the new capability that we have added to EKS API catalog, using which you can call this API to identify which versions are available for your EKS clusters.
So Kaushal, with this programmatic access, what are the use cases for customers to use this feature?
So as you know, Kubernetes releases 3 minor versions in a year, right? And our customers are advised to basically keep themselves up to date to the latest version of Kubernetes. Why is that? Because with every new version on Kubernetes community tries to address some of the security issues and also tries to add new features. And with this programmatic access to the versions availability, now customers can automate some of the upgrade stuff on their side. So they can identify which new versions are available, and if there is upgrade required, they can share those upgrades.
Amazing. So no manual triggering of your pipelines.
Yeah.
Awesome. Right, so on to the last update of this video, which is VPC Lattice supporting the TCP for VPC resources. So VPC Lattice is a service which allows you to connect your resources across different VPCs and accounts, and without the need of setting up complex networking using transit gateway or VPC peering. So giving our application developers design applications which can span across these VPCs and accounts. Now with the initial release of VPC Lattice, we added support for TLS, HTTP, HTTPS type targets. Now we've just announced the support for TCP type targets. Now how it supports container-based workloads. So previously you may have the requirement of running your container-based workload in the same account where you have your databases or other targets which were using TCP. With this release, you can now have your application span across multiple VPCs and accounts while making use of VPC Lattice. So again, another major update from this year.
Great, thanks Rohit. With that, we have covered most of the important container updates happened on AWS services in 2024, and we are going to make it more often in 2025. Thank you for watching and stay tuned.